In Chapter 10, we study acids and bases. We begin Chapter 10 with defining what we mean by an Arrhenius, acid or base. So we could define an acid as a substance that increases hydrogen ion concentration when dissolved in water. And it's important to realize that sometimes people will mention hydrogen ions, but that's exactly equivalent to protons, because a hydrogen atom has one electron and one proton, and when we take one electron away to form the hydrogen ion, what we're left with is one proton. So you will hear people say protons instead of hydrogen ions. We can define a base as a substance that increases hydroxide ion concentration when dissolved in water. A classic example of this is the ionic compound sodium hydroxide. When that's dissolved in water, it dissociates to form hydroxide ions and sodium ions. Another type of base are molecular species like ammonia that will react with water to produce ammonium ions and also hydroxide ions. And both of these classes of compounds meets our criteria for being defined as a base, which is a substance that increases OH- when dissolved in water. So a base might be an ionic compound that dissociates to form hydroxide, or it might be a molecular compound that reacts with water to form hydroxide. These two definitions are referred to as the Arrhenius definitions of acids and bases. So common Arrhenius bases are metal hydroxides, ammonia, and ionic compounds that contain the carbonate anion. Arrhenius bases are named according to the rules for naming ionic and molecular compounds that we described previously in Chapter 4. Arrhenius acids can often easily be recognized because their formulas will begin with hydrogen and end in AQ. And if you look down this list of names of common Arrhenius acids, you'll see that the names are not related to any of the rules that we defined earlier in Chapter 4. So it's important to realize that we have special rules to name acids. So acids are named according to the anion produced when they're dissolved in water. So here we have an acid. When it's dissolved in water, it makes H+, and it makes an anion. And this anion is a monatomic anion, so we call it the chloride ion. Remember that all monatomic anions are going to end in IDE. So as a result of this anion ending in IDE, we're going to name the acid as follows. We're going to begin with the prefix hydro, and then we're going to give the root name of the anion, which in this case is chlor. We're going to finish that off with the ending ic, and finally add the word acid. So for that reason, this acid is named as hydrochloric acid. Acids that form polyatomic ions when dissolved in water are named as follows. We have to look to see whether the ion that is formed ends in the letters ATE or ITE. So for example, this acid up here forms the nitrate ion. And for that reason, we make the acid will end in ic. So this will become nitric acid. If the ending of our anion ends in ITE, then the acid will be the us acid. So the nitrite ion becomes nitrous acid. So we have three rules. If our anion is an ide, then our acid was a hydroic acid. If our anion is an 8, then it's a little bit easier. Our acid is an ic acid, And if our anion is an ite, then our acid is an us acid. So we need to memorize those rules, or at least have a note of them, in order to be able to name acids correctly. When an acid reacts with a base, the H+ that is produced by the acid will combine with the hydroxide ion produced by the base, and that'll make water. Also, the anion that is produced by the acid combines with the cation produced by the base to make an ionic compound. And ionic compounds are sometimes described as being salts. So we can remember this with the following phrase: acid plus base gives salt and water. So this reaction at the bottom here illustrates that. The H+ from the acid combines with the OH- from the base to make water. The cation from the base combines with the anion from the acid to give an ionic compound, or a salt. So let's have a look at an example problem from the book. It says nitric acid can be neutralized by calcium hydroxide. Write a balanced chemical equation for the reaction between these two compounds and identify the salt, or we should say the ionic compound, it produces. So let's figure out the salt that's going to be formed, because we know that the other product is going to be water. So the base always provides the cation, and calcium's in group 2A, so it must be a 2+ cation. And then our acid always provides the anion. And the easiest way of getting the charge on the anion is to look at the number of hydrogens that are in the acid. And every hydrogen will give you one negative charge. So the nitrate anion, and we can double check that in a table of polyatomic ions, has a single negative charge. So now we use the crossover method to get the ratio of cations to anions, and we can see we need 2 nitrates for every 1 calcium. So let's think what we have to do to generate our balanced equation. The base reacts with the acid to make water and our ionic compound. And we just figured out the formula of our ionic compound. It was CaNO3 2. So fairly quickly I can see that I'm going to need 2 nitrates. So I'm going to go and put a 2 there. And at this point I realize that my number of hydrogens is not balanced. I have 4 hydrogens on the left and only 2 on the right. So I'm going to need to bump that up to 2 there. There we go. And now when I look at it, everything balances. I have 1 calcium, 1 calcium. I have 2 plus another 6, 8 oxygens. Then I have 2 plus another 6, 8 oxygens. We have 2 times 2, 2 times plus another 2, 4 hydrogens on the left, 2 times 2, 4 hydrogens on the right, as we noted before. And then finally we have 2 nitrogens on the left and we have 2 nitrogens on the right. So everything balances at the moment. Now a quick way of bringing this into balance, or helping you get to it being into balance, is to note this. Every hydroxide on the left equals 1 H2O on the right. So once you have everything other than oxygen and hydrogen balanced, you can always bring it into balance by making sure that your number of hydroxides on the left equals the number of waters on the right. Okay, so that concludes the video for section 10.1, Arrhenius definition of acids and bases.